All right, welcome to Math Made Easy. We'll be continuing the second part of sequence and series, and we're still looking at arithmetic progression, that's also known as AP. And this time we'll be looking at sum of an AP, and I told you that sum are series. I defined sequence as ordered list of numbers of terms, while series are what the sum of a sequence. So, like the example I used formerly when I used for the one I used for the sequence, right? This is a sequence. When you're having 1 plus 3 plus 5 plus 7, blah 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 blah, it's what a series. And basically the major formula in obtaining a series is this is the major formula in obtaining a series, and it works the same way. Let me give you an example. We have the series. Look at this. We have 1 2 3 4, right? Now if we are supposed to look at obtaining that series, if you look at this: 1 plus 3, 4 plus 5, 9 plus 7, 16, right? Now let's pick this one by one. A is what? 1. B is what? Plus 2. N is what? 4. Now the problem here is not how we add it. Let me explain so that you're not confused. So there's another second formula: n over 2 a plus n. Now if you remember, I told you that your n can act, we have tn, un, n the last time when we have a plus n minus 1 d, right? Now you have 2a. If you separate these 2a, we have a plus a, and this one will act as what? The l, if you get it. So we have 2a plus l. Sorry. Now let's look at this logically. If you are having your first term and your last term and they are following a sequence, just know that no matter how you want to do it, basically your first term plus your last term will definitely, what am I saying? Sorry. Look at it logically. You have 1 here, you have 7 here. Now what I'm trying to say, I will explain it with another one. Let's use 2, 4, 6, 8. Still 4 terms. Now you understand what I'm doing. I'll still increase the term, right? But I want you to understand what I'm doing, because I'm trying to look for a way to simplify this. I don't just want to give you formula and you don't understand it. So I'm looking for a way to simplify this. Now a plus l, 1 plus 7. Let's leave this n over 2. Let's come here 2. What is the first term here? 2. What is the last term here? 8. So we have 2 plus 8. Now why am I doing this? Look at this. So I have n over 2. Our n is what? 4 over 2. That's 2, 8. The same thing. So 10. What can you see here? What do you think happened here? Now let me explain basically what happened. I have to explain this, please. What happened here is that this thing is separated. Now I will explain what it means. Please get me. Let me explain. So look at this. Please get it logically. You have 1, 3, 5, 7. What it's trying to do here is that 1 plus 7 is what? 8. 3 plus 5 is also what? 8. Do you get the logic now? Now what is happening here is telling that you don't need to go through this hassle. If you do this, it's giving you 8. You do this, it's giving you 8. So why not divide the number of terms? What am I saying here? Instead of 4 terms, 1 2 3 4, 4 terms, we're adding it, so we have just 2. If we are doing something like 1 3 5 7 9 11. 1, 2, 3, 4, 5, 6. Now look at this. 1 plus 11 is what? 12. 3 plus 9, 12. 5 plus 7, 12. So this year we are having 12. Now this one got 1, 2, 3. Do you get it? Now why they are using a plus l is because it's from this a plus l they simplify to get this 2a plus this one. Now why they are using a plus l is because whatever you have with the first term and the last term, they also give you whatever you are having the second term and the second to the last term, the third term, third to the last term, till you get to the center. It's the same value you get because they are having the same common difference. So it's continuous value you get. Now, why is this n over 2 here? Because it is reduced. You see that we've reduced this 6 term to become what? 3. So if you are putting 6 here, it is surely reduced to become 3. The same thing we have 4. Usually, I don't know if you are getting what I'm saying. So the formula is now, if you are summing something, for example, they tell you sum of the 50, let's say first 50th first 50 terms, I think it will stop at 49, right? It will stop at 49. So the logic here, you don't even need this formula. What I can do, let me put 5 here so that you know that the common difference is 2. Since they have a common difference of 2 to 2, I'll just put the first and the last. 49. How many terms are we having? 50 divided by 2, 25. But they want something that will be structured in a way to know that you are learning, not just rule to the answer, right? So that's why I'm trying to explain how this formula came about. Right? So if you are taking the first term and the last term, you add it together, multiply by the number of terms divided by 2, because if you are adding it together, 1 plus 11, it will reduce your term from being 6 to 3. I don't know if you get it, because that is the sum. So that's the logic being used. Then sorry for the rough one. Yeah. So let me just give an example. So basically, we just use this formula. No, everything remains the same. It's just that, sorry for that. It's just that the Sn now will be called sum of terms. Do you get it? Now the formula is n over 2 into bracket 2a plus n minus 1d, or n over 2a plus l. Now you can use a plus l anytime we tell you the last term. Anytime we tell you the last term, you get it. So now let's look at this question logically. I think I've tried to solve. Okay, I'll solve. Go back. I'll solve with this. Now, if you see something like this, you can't use this formula because we don't have our n. This is infinite. It keeps going, right? So we can't have our n. I think there's no distance. It means our n is what? 7. So if they give me this and they say find the sum of the first 20th term. Now what you do, your a is what? 1, d is what? Plus 2, n is what? 20, because you are finding the sum of the first 20th term. So we use S20 using this formula. N will be 20, 20 over 2, right? 2, 1 plus 20 minus 1, 2. So we have 10, 2 plus 19 times 2, 10, 2 plus what? 38, 10, 40 equals to 400. So this is the sum of the first 20th term. Now if you do it logically, you keep adding blah 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 till you get the 20th term. 20th term should be like 39, if I'm not mistaken. 39. Now if we do it that way, we'll see that 1 plus 39 is what? 40. How many terms? 20 terms. So if I are doing it 1 plus 49 40, then it will be divided into what? 10, because that 20th term has been reduced to 10. So we'll do 10 times 40. You see, it will still give us the 400. But it has to be structured so that they will know that, okay, you know what you are doing. So let's take the second question and we end it here, because um, it's possible that they give another type of question which is not this. Because you can see a question, I'll use that similar question, but we'll look at something. If the sum of the first 20 terms in an arithmetic progression is 400, and its common, or let me say last term, is last term is 39. Find, I think I've come across question like this. Find A, first term, B, common difference, then the last one C, sum of the first 50 terms. Now, how do we solve this? Sn, this is A, let's solve for A. We know that the formula is Sn. Let me not write the formula first. Let me write what we have. We have n is what? 20, Sn is what? 400, and n is what? 39. Now, let's solve for A. Sn equals to n over 2 A plus what? N. Why? We are using it to find the first term. We have the sum of terms, we have the last term, and we have the number of terms. Let's find the first term. So Sn is what? 400. N is what? 39 over 2. We don't know A. A plus what? N is what? Okay, no. N is 20. A plus 39, right? We have 400 equals to 10. A plus 39. Abi, we have to by 10. 40 equals to A plus 39. And now come to the side. 40 minus 39 equals to A. 1 equals to A, or A equals to 1. Now, you see that if you look at it, our A is 1. Do you get it? Now, simple, you can use the other formula to get the common difference. N equals to A plus N minus 1 D. Still using N as 20. So N is what? 39, because we know A now is 1 plus N is what? 20, right? 20 minus 1 D. 39 minus 1 comes there, becomes plus 1 comes there, becomes minus 1 equals to 19 D. 88 equals to 19 D. Divide both sides by 19. D equals to what? 2. Do you get it? Now they say find the sum of the first 50 terms. So now our n will change from 20 to 50. So using this formula, first 50 terms. Now for the 50 terms, we will not use n again, because n is not going to be our 50th term. 39 was our 20th term. Our 50th term is not 39. So we'll use this one. So we have S as for C. We have S50 equals to 50. I mean, S50 equals to 50 over 2, open brackets, 2 times A is 1. I think I need to clean this so that there will be more space. I need to clean this. I don't know. We already grabbed how I got the first term, A and B. First term and the common difference. So I want to clean this. Sorry for that. I want so that there will be space. So for the C, we have Sn S50, right, equals to 50 over 2, n over 2 into bracket 2, our A is what? 1, right? Plus 53 minus 1, and we know that our common difference, we've gotten it in B, that was 2. So we have 25, 2 plus 49 times 2, right? 25, 2 plus 50, 25, so not 50, 98, 2500, right? So our S50 is going to what? 2500. So that's how to get some. So I don't think if we have this variant of question, the other variant of question, there should not be any question you're not able to solve when it comes to sum up and arithmetic progression. So see you next time. Next time we'll be talking about geometric progression. Thank you very much.